My first job in 1974 was with a little company that was working for NASA. I was a contractor. A few years later, JPL absorbed me. Jet Propulsion Laboratory has two areas. The spacecraft side, they design and build the spacecraft, and the Deep Space Network side, which I belong to. We are an important part of the space program because once they launch the spacecraft, it's us who does the tracking and commands. I worked for Erector's company after I had my degree and license. Worked for Erector's, and I worked at the construction of the Central Bank of the Philippines on Rojas Boulevard. And we left the company, four of us. We formed a little consulting firm, and that was my last year here before I left for the States. I started looking for a job, and it was not very easy. They asked for a local degree or local experience, which I didn't have either one, right? So I changed my focus to getting not an engineer but a lower position. I got in as a structural designer. My drafting training from College of Engineering came in handy. So I was on the drafting board. That's when I decided to go back to school, get a master's degree so I could have a local degree and a local experience. I had a civil engineering degree, USD, but civil is divided into structural engineering or hydrology or environmental. I opted for structural, and that's where I had an extra training. Deep space is when we send spacecraft to different planets. That's millions of miles away. There's a difference. So our antennas are like 70 meters in diameter. The surface area of that is bigger than a football field, just to get the idea of how big this is. This paraboloid needs the antenna. As it tips in horizon, it changes because of deflection, right? And that's how we design it. It has to conform to the prescribed RMS, or root mean square, of the surface area. There was a program invented by my mentor, Dr. Roy Levy. It's called IDEAS, IDEAS. It's Iterative Design of Antenna Structures. And this is just for antennas. Or we have our own wind coefficients depending on how the antenna faces, and seismic, of course. The two loads are the seismic and wind. But normally, seismic doesn't even come into play because we're very far from destruction. But we still check on that, make yourself safe. Missions, for example, to Mars are just specific, planet specific. You just orbit that and take pictures. And the Mars lander, they take samples and they analyze it there and send the results to Earth. In engineering school, you get trained with steel design, which is antennas are made out of steel, but it's also made of concrete foundation. You have to reinforce concrete engineering and structural engineering for steel, and of course geotechnical, which is earthquake. You have to be good at that. Those are the subjects that are given in the board exams for civil engineers. By going structural engineering, I concentrated on the design of structures and foundations, because that's what I used at JPL. All I can say is I was just a little above average student, but I, became successful in life later on. So this is I'm an example of the majority of the students that you can still make it even if you're just average,